Very good morning to everyone. Today, this lecture is going to discuss about the CMOS inverter using LT Spice. So we prepare one CMOS inverter with the help of LT Spice schematic editor. So here we use firstly to draw one CMOS inverter using PMOS and NMOS to understand the circuit design. So here, this kind of circuit you generally seen one PMOS in series with connected one NMOS, the source of PMOS connected with the supply voltage, that is VDD, and the source of the NMOS is connected with the ground connection. This is NMOS. So this is ground. The drain terminal of both PMOS and NMOS connected with V out, and the gate terminal of both PMOS and NMOS connected with V in. So this kind of circuit, this is P, this is N. So this is basically a CMOS inverter circuit. CMOS inverter. So now we prepare this circuit using LT Spice software. First we clear this. So now we go to the LT Spice software. LT Spice is freely available. So you can download through the website of LT Spice. Now go to this file, draft 1 and draft 2. So we use only single file, draft 1, and there is a lot of option you can choose. So there is a component library. A is for labeling net, F4 is the short key. This particular symbol is used for ground connection. This is wire. This is move key. Okay. So click on this component and type here PMOS. It will give two PMOS and another one is PMOS 4. So we select PMOS 4 as a 4 terminal device here. Click OK and you will get one PMOS here. Now click right key of the mouse button or escape key. So this selected PMOS will disappear. Now again go to this component library and click NMOS. Type NMOS here. You will get again two options, NMOS and NMOS 4. So click NMOS 4 and press OK. So here you will get NMOS with 4 terminal device. Now go to the wire and connect all the terminal. Both the gate are tied together from PMOS to NMOS. This is your V-in connection. Source of the PMOS will be connected with the VDD and source of the NMOS will be connected with the ground. Okay. Now this is your V out connection between both the drain terminal, and this is your V in connection between both the gate terminal. Okay. Now go to the labeling key, label net. Here you will get V in. You type V in of the net name. This is your input key. So select port type as input. of V in. You can take V as a capital letter or a small letter, whatever. So this V in as an input key, press OK, and VDD, again input type, press OK, connect at the source terminal of PMOS, and next one is V out. This is your output pin, press OK and connect it with the output node of this inverter. Now one more terminal is left, this ground terminal. So take this ground connection from here and connect with this ground connection. Now this center body terminal is open here. So we connect with this wire and connect it with the source terminal for PMOS, and same we do with the NMOS. So this NMOS and PMOS, this kind of connection is known as zero body biasing. Means body will be tied to the body will be shorted with the source terminal of each device. So there is no voltage drop. So it is called as zero body biasing. Now there is two biasing is required, that is V in and VDD. So again go to the component library, type voltage VOL and you will get voltage here. Press OK. So V1 and V2, put it ground connection with all the voltage supply, and now there is a copy key. So we select this copy key and use this terminal, because this voltage source represents your VDD voltage, and again this V in V1 voltage is represents as a input voltage. So now this is your complete design. Now we come on to this symbol V1, click on the right button. This will give the voltage source property. Here we will select V in as a 0 volt. So type 0 only, and on V2 click right button of your mouse and VDD will be 5 volt. We take 5 volt here, click OK. So we will give input voltage as a 0 volt and supply voltage as a VDD of 5 volt. Now we save our design. So we can use save as from the file, and we will type CMOS INV, means inverter, CMOS inverter, and save. So it will be saved in the LT Spice default location. Now this file will be saved. Now we run this simulation of the prepared device. So we use stop time as a 10 microsecond. Now this simulated window will be here, and when we move on to this our design, this pen or our simulated tool will be appear. So we click on this V in and click on this V out. So once we maximize this window, Here we will directly see the green color is represented your V in voltage, where we already taken 0 volt as a V in. So at 0 V in, we will get 5 volt or higher voltage at the output side. So our V out will be 5 volt. So this is our first kind of simulation output. Again, we take input as 5 volt, save this and simulate. So here we see our input is 5 volt and this blue color line will be at this origin 0 volt. So at 5 volt, our CMOS inverter give 0 volt output, and at 0 volt, this will give 5 volt output. Now we take input voltage as a pulse. So once we go with the advanced option of this input values, so here various option: pulse, sine wave, exponential wave, and so on. So we take pulse here, take 0 volt as an input, sorry, initial value is a 0 volt, V on is 5 volt, delay time is 0, rise time 0, fall time 0, on time is 2 nanosecond, total period is 4 nanosecond, and 20 pulses we required here. Now again we take the simulation for this given pulses input. So V in and V out. Okay. Why this kind of curve is appear, this kind of waveform? Because we have taken 10 micro second as a transient time. So again we move on this and change this value from 10 micro to 10 nanosecond, or we take a 20 nanosecond for safe side. Okay. Now again go for simulation, and here you will get your perfectly simulated output. This green color is your V in from 0 to 5 volt, and then again it from 5 to 0 volt, it is a pulse from 0 to 5 and 5 to 0, and the blue color is the complemented output. This perfectly give the characteristic of an inverter. If this graph is if this graph is uh, not visible clearly, so you can add this plot pane, click on the right button on this graph and add plot pane, and you just drag V in from here to this new window. So now this V in and V out waveform is appear here, and so this is your output of simulated CMOS inverter. So thank you for this time. Now we will see various complex circuit in our next lecture.